Look up at the night sky. Those tiny points of light seem eternal, but every star has an expiration date. Some will fade quietly, while others will explode with unimaginable violence. The death of stars is the engine of the universe, and its story is more dramatic than you can imagine. For billions of years, stars shine by fusing hydrogen into helium in their cores. This nuclear fusion creates energy, balancing gravity's relentless pull inward. The smallest stars, red dwarfs, can burn steadily for trillions of years. Our Sun, a medium-sized star, will shine for roughly 10 billion years before its own demise. But the larger a star is, the faster it burns, and the more spectacular its death will be. Stars are cosmic furnaces. Their lives are measured by the delicate balance between pressure and gravity. When fusion finally ceases, gravity takes over, and the star begins a dramatic transformation. How a star dies depends on its mass, its composition, and the environment around it. These deaths are not mere endings, they are beginnings, seeding the universe with the elements needed for planets, life, and even future stars. The smallest stars, those less than half the mass of the Sun, live slow and quiet lives. Red dwarfs burn their fuel so efficiently that they can shine for trillions of years, longer than the current age of the universe. When these stars finally run out of hydrogen, they do not explode. They gradually shed their outer layers, creating a dim glowing shell of gas known as a planetary nebula, while the core collapses into a white dwarf, an incredibly dense, slowly cooling remnant. White dwarfs shine faintly for billions of years, slowly radiating away the last of their energy. Even in their quiet death, these stars shape the cosmos. The gas they shed enriches interstellar space with elements like carbon and oxygen, ingredients essential for the next generation of stars and planets. In a sense, red dwarfs die quietly, but their deaths are seeds for cosmic renewal. Our Sun is a medium-mass star, and its death will be more dramatic. In roughly 5 billion years, the Sun will exhaust its hydrogen fuel. Its core will contract, and its outer layers will expand, turning the Sun into a red giant. Its surface will swell so large that it could engulf Mercury, Venus, and possibly Earth. Eventually, the core will shrink into a white dwarf, just like a red dwarf's, but the process will generate a spectacular planetary nebula visible across light years of space. The Sun's elements will be flung into space, enriching future stars, planets, and perhaps life itself. These deaths are not violent, at least compared to massive stars, but they are beautiful and vital. Astronomers can observe countless planetary nebulae throughout our galaxy, glowing shells of gas that testify to the death of medium stars, often with intricate shapes caused by stellar winds and binary companions. Massive stars, more than 8 times the mass of the Sun, die in the most spectacular fashion. Their cores burn hotter and faster, fusing heavier elements like carbon, oxygen, silicon, and iron. But iron cannot release energy through fusion. Once a massive star builds an iron core, it has reached a dead end. The core collapses under gravity's immense pull, triggering a core collapse supernova, one of the most energetic events in the universe. In a fraction of a second, the core's over implodes, then rebounds in a shock wave that tears through its outer layers, releasing more energy than the Sun will emit in its entire lifetime. The explosion scatters heavy elements across the galaxy: iron, gold, uranium, the building blocks of planets and life. The core left behind may become a neutron star, a city-sized object with the mass of the sun, or a black hole where gravity is so extreme that not even light escapes. These deaths are violent, luminous, and rare, but they are the ultimate cosmic forges. Without them, the universe would lack the diversity of elements required for planets, chemistry, and biology. Supernovae also shape galaxies, pushing gas and dust into interstellar space, triggering new waves of star formation. They are endings that create beginnings. Some massive stars die even more spectacularly. Hypernovae and gamma-ray bursts can briefly outshine entire galaxies. These events are so powerful that their effects can be felt across millions of light years, and they remain some of the most mysterious phenomena astronomers study today. Whether quiet or violent, the death of stars drives the evolution of the cosmos. Planetary nebulae enrich interstellar gas. Supernovae seed the universe with heavy elements. Black holes form, warping space-time and influencing galactic structure. Even the light from dying stars can be measured billions of years later, allowing astronomers to reconstruct the history of the universe. Our own existence depends on these deaths. Every atom in our bodies heavier than hydrogen or helium was forged in the core of a star that has long since died. The oxygen we breathe, the iron in our blood, the gold in our jewelry, all come from the final moments of stars, exploding across the galaxy, seeding future generations of stars and planets. Stars may die, but their deaths are never the end. They are transformations that fuel the universe, creating the elements, the planets, and even life itself. Next time you look up at the night sky, remember, every twinkling light is a story of birth, life, and inevitable death. And from that death comes everything we know. If you want more real stories about the universe, its stars, black holes, and cosmic mysteries, subscribe to the channel. And tell me in the comments, which type of stellar death fascinates you most? Quiet fade or explosive finale?